no walls or walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a rule. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight low says. Mike building batteries that power a ship. Victor comes and talking math as the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tones from the prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
Hello everybody, welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
Hey, Nathan. Everybody, TGIF.
Oh man, dude, it's gonna be an awesome week, bro. It's been fun, man. I got back from Tesla Tech, and dude, it was rocking there, bro. There was a lot of stuff to do. It was like things started at 8 o'clock in the morning, man, and they didn't end until like 10:30 after everybody ate. So, but it was cool, man, because it was like community breakfast. Everybody ate the same place. You know what I mean? Community dinners. Everybody ate at the same place. And dude, everybody was totally cool there. You know what I mean? Come sit down at the table, hang out with us. You know what I mean? Get to know everybody. Dude, totally wide open. No ego. I didn't see anybody with an ego there, dude. It was all like, hey, come on and talk with us.
Oh, that's awesome. And that's really what you could, that's the dream.
Oh man, Joe, I think you froze on us, bro. Oh man. Hey, yeah, look, dude, when Joe figures that out, man, I'll just tell you guys a little bit about my presentation and stuff. Dude, I got up there, man, and I gave it out like I usually do here in my garage, and I talk about things and stuff. Dude, it was awesome. The reception was absolutely unbelievable. They understood exactly where I was coming from. I had linked everything in cold energy experiments, you know what I mean, to what we were doing with ions and things like that. So they were appreciative of that. We had talked about as well in there in the presentation about how you get to over unity in certain things, you know what I mean, and how we reverse engineer certain things. And I just gave out some secrets there, man, that nobody probably understands or knows yet. And, I made it real quick and easy for everybody, man, and just got up and became the presence in the room. I started out, man, no slideshow, no boring, no put your head down and kind of groan through it. It was me up there live. You know what I mean? I'm going to grab your attention. I'm going to use my big voice and my big fat ass up there to show you, hey, I'm going to draw you in, man, with what I'm saying. And then I'm going to give you the goods. You know what I mean? So at the end there, man, I gave them all the math. I did everything I promised I was going to do. I gave them the equations. You know what I mean? Talk about enthalpy pumps and stuff like that, and how do we do it, and how do we make gravity in a gravity well. So, yeah, I mean, dude, like one person said, they came up to me and goes, you didn't even mess around, man. You just flat out said it for what it was. No beating around the bush. No hiding things behind something else. No patents, nothing. You just came out and said it for what it was and challenged people to prove you wrong. And that's what I do, So I was appreciated that people understood that. You know what I mean? Like I didn't come there to, sit around and sit on my fist and lean back on my thumb. I came down there to present and say, hey, this is the way it is. So that was really cool, man.
That's awesome, dude. It's a bit refreshing given the environment of everything we talk about, everything that we do, for there to be a meeting of the minds where the stuff isn't just inherently met with reluctance, resistance, and all that sort of stuff, where they'll actually hear what you're saying and then put it to the, put it against the test. Because most of the time we have these conversations, especially with anybody with credentials, it's like hitting the wall right there.
Yeah. Well, common language helps. So every bit of, hey, you know what I mean? Let's put it under an envelope everybody can understand. Let's make parallels that you can't get away from. Let's, dispel myths that you're used to talking about and regurgitating, you know what I mean, through physics. And one of the things that I think hit the hardest, man, when I told him, I says, you don't think of hot and cold. You think of everything from the point where you can see the light, and that's the way physics does it. But the first thing they do to get superconductivity is they freeze it. They put it in ice cold. Why do you think that is? So when I sit here and I talk about the cold and things like this and the environmental condition, you must understand in order to get there, you must have this component, which means you're missing one. And if you're missing one, you have incomplete numbers and incomplete math and incomplete physics. When you complete it, the anomalies go away. The power starts to show itself. And that's kind of what grip people, because they're like, oh, we got somebody that's pulling off, you know what I mean? How to get to superconductivity in every single thing, which means that your system can run all the hot energy at once as long as it has no impedance on the cold side. Then, you know what I mean? You pretty much got it. And the rest is all transformation of energy. And I made sure I pointed that out. That, hey, we're not losing any energy. In an entropy pump, you're a transfer of energy. You take the energy, the heat, you transfer it back into the system. There's no getting around it. And I made a point, Joe, just because you made a point to me about Maxwell's demon. And here's the thing. In Maxwell's demon, you have the cold and you have the hot, right? And it's up to him to decide which one goes through, right? But in EHD, MHD, that's exactly what you're doing. One's the hot side, one's the cold side. You are the controller of Maxwell's demon, right? You're the guy at the door opening and closing the door. And I made sure I told this to people when I was there so that they'd understand this. Hey, we're controlling the EHD, which is the electrical, right? And then we're controlling the MHD, which is the magnetic, which is the heat, okay? So we're controlling both. We decide which one goes where. So in the system of an EHD, MHD, the reason it works as the pump is because it's pulling ions through it and pulling energy through the environment through the pump. It's never letting the energy out. That was the point. And it's through AC that we do this, and everybody knows my stance on this, man. If you run something in AC, you can change the frequency and change the voltage and amperage at will. I've showed it on my channel as a test. It's real easy. As long as you understand that, man, you know how to couple with the environment, this thing actually becomes pretty fairly easy to put together at a testing basis versus just theory.
You're dead on, man. And, it's okay. So it's something you said a long time ago, and it evolved over time. And, you were right when you said it, but the context just simply wasn't there. It wasn't built up enough. But it turns like one side of it, and well, kind of both sides of it, it's an asymmetric leaky capacitor that realistically is the Maxwell's demon aspect of it, and why a leaky capacitor? Because it's not about the capacitance discharge. It's about, the dielectric breaking in that capacitance and then having an exchange, an environmental effect on the exchange outside of that K value break. So, yeah, that's sort of the critical thing to understand is the asymmetry is what keeps it perpetual. Because if it were just simply symmetric, where -1 + 1 = 0, well then cool, it collapses. And there's a lot of effort put into equilibrium, and symmetry, because they feel that the symmetry, the symmetry is required for the stability, but it's actually the opposite. See, geometrically, it's symmetrical, but in order to get the geometric symmetry, there has to be an inequality in the exchange.
Yeah. Let me shout out Jarvis here real quick. Jarvis, thank you very much, brother Vortex. Thank you, man. I appreciate this. Totally
Right on.
awesome, brother.
Definitely.
So, yeah. Oh, dude. Shout out Ian, brother. Ian is awesome, my friend. Okay.
Oh,
I'm, and
I'm glad you met him, but I knew Ian was awesome generally. Shout out.
dude, we hung out at the bar. We hung out, you know what I mean, eating breakfast, eating dinner. You know what I mean. Ian brought his project to Tesla Tech, dude. Let me just tell you something. He instantly had a crowd around him, man. They all wanted to talk to him. Superstar Ian. He went out there and interviewed, man, on some channels out there so that they could figure out what's going on. There's always somebody at the booth with him. Shout out Bernie, man, for hooking him up for that booth, man. But that was, dude, Ian's the funnest guy in the world. I truly appreciate him, man. Right on, brother. So,
Nathan was
and,
the first one to tell me that, Ian totally stole the show. Like with his booth and everybody coming up to him. So, props to you, brother. You're a huge part of this too. You always have been with your banks and everything that you do, and we love seeing it. So, come back sometime. Why don't you?
yeah, dude, it was a good time, man. I met some people there. Dude, I got to write down names and stuff. Some people that are on the channel, man, that have been watching it for a while. They were like, you know what I mean? Nathan, it's good to see you in person. And I'm like, dude, I don't even know that you knew me. You know what I mean? Like, from the channel. And it was just kind of cool to kind of be in that feeling for once, like you got recognized for what you do. So that was an awesome thing, man, all in itself. You know what I mean?
Yeah, a lot of people catch us after the fact, right?
Yeah.
And a lot of people watch the videos after the fact that you put up too. So not everybody's engaging all the time. So there's a whole entire abundance of people out there that they know us, we don't know them, but it's awesome to see that people literally made a pilgrimage, to see it through and everything, man. That's awesome.
Yeah, I'll have to break out some pictures, man, for next week so you guys can see them. They had that little heated chamber booth thing, man, that they sit in for a sauna, I guess it is, and relaxing things. One of my buddies that came down there, man, I can't get his hashtag right. It's MAG4 something. And anyway, he's a really cool guy, dude. We were hanging out over there, and he got in one of those things, man. So I sat there out there talking shit to him while he's in there, man. It was hilarious. But no, it was real fun, man. We got to hang out quite a bit, dude. He hooked me up with a Rodin coil. It's a little small one. Okay, I'll show it here in a little bit. But the geometry is different, so it angles in, and it has a higher volume of the center point. Okay, and it was like mathematically right on where we're going, man. And he had been watching the channel, man, and he said, "Hey, Nathan, this is the way to go." So he hooked me up and gave me that, man. I got to put it in a test, and I'm gonna shout him out for it, dude. Thing's totally awesome, man. So, yeah, that's the kind of cool stuff that happens there. You know what I mean?
Yeah, man.
And then we got to see some stuff down there, that some Bedini motors. Dude, cap bank the Bedini motor, right? So you do the Bedini motor and you throw it right into a cap. You convert immediately to DC, okay? And then you fill the batteries with DC instead of an AC spike. Yeah, 3D have it. So, oh man, no, he wasn't there. It was a different guy. Sorry, I'm reading the wrong thing. So anyway, he converted it over and he was showing the pulse rate and everything like that, right? It was totally cool experiment. So I thought about it and I go, how would you show this to show over Unity? Okay, how do you take this cap bank and show that you're charging batteries, right, and do this? The only way that Bedini did it was to show I got a huge amount of batteries, right? And I'm going to charge them all at once. Well, why not take it a step further? We'll go get some go-go scooter batteries, okay? And we can ride the scooter with them to show them that the energy works right? But then you take the power side and you take two of them and you have an A-B switch from a boat, okay? That's it. So that it automatically goes over without losing energy or turning off your engine. You know what I mean? So you put that on the left side. On the right side, you put the capacitor bank in 3 rows. And we build 3 separate circuits for each row, 3 batteries in each row, and have an individual shut off for each battery, which means that at any point we can take out any one of the batteries that we want and use it. So if you're showing the one side where you're taking 1 battery and you're charging 9 batteries, right? But then you say you could take any one of them out that you want, go over and put them in a scooter and drive the scooter. One, you're showing it's DC, right? No questions. Okay, it's workable energy. You don't have any problems with it. Second thing is, what's the charge percentage? How much does it take of that first battery to get to all those being charged, right? So that goes away. You're saying I can charge 9 batteries with one, okay, through this machine, which means I definitely have over unity in the machine because your multiplier is huge, right? So that's one way to show it, man, and it's usable energy, and that's not going to take very long. It would take me building a second Bedini device, changing some of the stuff on it, putting a third sucker board in the back, and 2 extra driving coils, and then a cap base. You know what I mean? A couple switches, and we're done. But that's one of the things I looked at. I was going around going, man, nobody's selling Tesla coils here. You know what I mean? There was one guy, Hackensack was over there selling one of his Tesla coils. By the way, he hooked me up with one, man, an old school Tesla coil, like the way Tesla built them. So that's going to be on my channel too, man. That guy's awesome, man. I talked to him for quite a while. We had a lot in common. But yeah, there was a whole market there that I missed completely. You know what I mean? That I could have just showed everybody the whole world, put my hands in the water, you know what I mean? And showed them a whole new way. So I think for next year, you know what I mean? We went into this year talking about some anti-gravity stuff. I think next year my focus has to be hitting over unity. You know what I mean? I'll do the SG. I'll make it work for over unity. I'll show conversions. And I'll just straight take your energy and I'll convert it right in front of your face. And that way people can really get it. Kind of think about it. They say that the energy in the environment's weak, right? I don't think so, man. I think they got it wrong. And I'll tell you why. It's kind of like the Rodin coil. When you put the energy into it, there's no iron to make the magnetic field, right? So let's fix that. Let's just take a simple understanding of energy. High voltage line goes into a little bucket. In the bucket, you have a 3-leg transformer in there, and you have mineral oil. Before that, you have little windings that sit at the top. They start to set the environment, go from high voltage at 1,000,000 volts down and very microamps, and that goes right into, you get usable voltage, right? So if you think about that, that's the same thing we're doing with environmental energy. What's the difference? There's a backstop on the high voltage line. That little thing right above it, when you come right off the line, there's a backstop, okay? It allows it to go through in one direction like a diode. Does not let it to go back through, so it's a backstop. It pushes it into the bucket. The bucket then transfers it over to AC, right? The AC sloshes. So it works as a cold energy experiment because the cold energy pulls everything in, but that's what your house does, right? So we start thinking about it in those terms, and we go, okay, so all we need to do is put a 3-legged transformer in a bucket of mineral oil. We need to create the backstop diode in order to do it, right? So that it'll go through, but it can't be in a regular diode form. It must be in a curly wire, okay? And when you get that curly wire and then you put it in resin, you start to change things, right? Because it immediately puts a small amperage on it, brings it back, gets it a backstop, pushes it in there, the bucket converts it, gets you right over to AC, right? If I show that conversion, it changes everybody's mind. Now weak energy becomes, that's my wall energy, dude. How did you just take that Tesla coil and make my wall energy? And it's like, well, because I followed the same thing they did a long time ago. This is where it really matters, because when you get to it, there's people who already knew this. You know what I mean? Steinmetz already knew it. He knew the answer to this. They tried to write it in a book and they wouldn't let him publish it. GE said no. So this is one of the things that need to come out. So I think next year we'll do over unity energy conversions. You know what I mean? Show exactly how every single system is converted. And then it just eliminates the lie. I'm just going to flat out blow it out of the water and eliminate it. I think that's what I have to do. You know what I mean? To really get everybody kind of on the same page. I want to shout out Darren here. Darren, thank you very much, brother. I really do appreciate it, man. Right on. What do you think, Joe? You think that's the right way to go?
I mean, I do, but, I have a little bit of a bias because, I mean, the SG circuits are definitely, there's something there. But I'm a little biased, and I still think that the Rav is sort of the pinnacle of it and the most relatable. I think it's the most relatable because the direction of new, you know, new energy is going in the direction of fusion in the first place, and the way that they're doing the fusion is all fucked up and wrong. And this is taking it and showing that there's a more simplistic approach that could use significant optimization, um, a better direction, frankly, from where we've taken it, to actually show it. But that's why there's 12 months between now and then. Um, I think that the implications of it are better because, not only does it have the potential to show over unity, but it also has the ability to have a much deeper implication, right? As far as material science is concerned, through like literal alchemical transmutation potential. Connects the dots between all different energy types, and still manages to show the Maxwell's demon as well as the entropic exchange, the huge reduction in resistance through near superconductivity. I won't call it superconductivity, but high efficiency conversion and resonance. So it takes every bit and piece that we generally like to talk about. Excuse me. Every bit and piece that we like to talk about. And rather than just have them be buzzwords of a single function, it takes all of the functions, combines them into one, functions that people are already aware of, interested in, experimenting on, with the direction being the same. And then really you want to talk about mic drop and, said the quiet part out loud. I think that's the ultimate, because it's like I had been discussing amongst ourselves earlier. There's a deeper reaching implication of the energy exchange that occurs in RAV. You see, and it's happening at different degrees, like even in the SG circuit. That's making a high efficiency equation and then using a multiplier across the board that's allowing you to expand to 9 batteries or whatever you're saying, to be able to charge it. And that's sort of the point. But, that's not the only implication with RAV, right? The fact is that process that's going on with RAV is the omnipresent process. It is the process that destroys and builds matter from the fundamental particle level. It doesn't get much more inclusive than that. It is a miniature version of a planetary system. It is a macroscopic version of the atomic system simultaneously, because all of these processes work on all these levels, and when the fundamental particles come together to form an atom, okay, they're working off the same exact forces that are at play with the field couplings and the asymmetric stability relationship for them to get locked into the position that they're in. That's why an atom is so stable, is because it's locked in that stability phase, and then it multiplies. Now you have many atoms. Now they form that relationship based on their constituent components. That then structures them out further. And then that's what we consider matter. But at the end of the day, it's all just energy. And it's really, more specifically, it's energy and then collapsed energy into matter, then interacting with one another at that level. So it's kind of going these couple tiers in, I just think that's the ultimate. When you graph it out, you explain it properly, you show it, and then if you have the proper data to back it up, then it's blown wide open. There's no other conversation that has to be had. There's actually not even implications that have to be made, because even if you don't have a device that specifically does any one of the implied functions, the proof of concept to attain those applied functions is present. and the data numbers are there for you to understand the scalability of it, to then know exactly what you have to do to achieve that end.
Mm.
So that's what I think. I think anything short of that, and I'm not going to say is a waste of time, but it's a waste of time. It's there's a reason it's special, man. And there's more than one way to skin a cat, as they say. I know you like cats, you know.
He knows to get him, that's for sure.
Yeah, but like at the end of the day, like there is always a best and fastest way. There is a more the most complete way, right? And I think that's it.
Well, I think, to be honest with you, I probably need you or Sean there, and we present together. You know what I mean?
That's it. I said I wishing I hope for the opportunity to make that trip next year.
Yeah, if you could get there, man, then we could do two presentations, and I'll do one, you know what I mean, on the over unity, and then how to transfer energy, and then we could do the RAV. Dude, we could totally own Tesla Tech at that point. You know what I mean? I think that would be awesome.
And we'll just between now and then just have to pave that way forward. That's all. We'll have to come up with a get Joe to Tesla Tech fund instead.
We gotta get Sean to be able to go, man. Get him some health pills, man. Get him up and going. Then we make him go with us. Dude, he'd have the time of his life, man. So I just want to answer this question. How did your presentation go? Look, they sell the Tesla Tech, so I'm not allowed to show it. You know what I mean? You can purchase it from them and check it out. If I get a copy, you know what I mean, and if they let me, I'll put it on the members thing for everybody to see. But other than some, you know what I mean, times where my mind lapsed, where I couldn't say the right word, you know what I mean, or I had a light in my face trying to read a teleprompter, you know what I mean. Other than those two things, man, it went perfect. Dude, the information got across, people understood it. People were asking me questions all week, dude. Like, how do you even know this stuff? You know what I mean? And I keep telling them, I go, well, every Friday, man, we're discussing it. You know what I mean? We get down to the point of what we're doing. And that's kind of how it works. Joe and I work on that end. Sean works on the physical end of building everything. You know what I mean? I usually work on the other end of trying to get everything detailed and precise when I build things. You know what I mean? And it all comes out, man. All of our work shows. And then Richard's over there going to break our minds here this year. I swear he is. The stuff that he's doing, man.
In the works, That's
and
he's all hands on deck, and he's also got all of us at his disposal as needed. So, that's really going to come about.
Yeah, man. I wanted to ask Richard too. I want to get Ian hooked up with that program, man, because you should see Ian's cheat sheet. Okay, it looks like John Gruden's play calling sheet. Okay, massive sheet with giant things on there, and then you flip it over, and there's more on there. I'm surprised it's not all highlighted. Dude, he's got this cheat sheet that goes on for his Arduino stuff. I thought was awesome because he's over there tracking everything that's going on, and I'm thinking, dude, this is what we're doing. You know what I mean? This is what we're trying to achieve at the same level. You know what I mean? We're tracking everything and doing everything. So I'm thinking we need to get a hold of Richard, and of course Richard will take care of it, man. And that's kind of what we need, because next level, brother, next level. Vortex, brother, right on, man. Appreciate it.
Hey, so let me ask you. So who, out of the people there, who kind of like had the most traction? Like, what kind of like caused the most like excitement out of that?
Okay, so a couple things. Mr. Howard wasn't there. You know what I mean? So we didn't get to hear from him. There was another gentleman there, and for I don't know what reason, dude. I just don't know who he is, but he's a very popular guy who's in there talking about science of the liver and how they regenerate it and stuff like that, and how they think we're making another one based on a programming thing. And he's apparently a CEO of multi-million-dollar, billion-dollar company. I have no idea who he is, dude. I don't track that kind of stuff. You know me. But congrats to him. He presented there. He was kind of like one of the main attractions, going into there. And then obviously Bob Greener. Like, dude, he got up and started singing songs. Okay, I thought we were in Saturday morning cartoons as soon as it started. Man, it was all him. Once you get to know the guy, then it makes perfect sense, right? But if you just watch that on the blue, you're like, what the? That doesn't show up on his channel, right? But then in person, that's kind of who he is. He's really excitable. You know what I mean? He's like always zooming somewhere, even though he's just going normal speed. To me, it looks like he's super fast. You know what I mean? But Bob's a character in itself. Oh yeah, dude. Everybody knows his work. You know what I mean? Everybody's right there. I think he filled the whole entire thing, man, up with people, and they were all there to watch. Dr. Yu did good, man. I always like listening to him. We met him on Mike's show over there at Faraday Research, and I got to meet him personally. Here was kind of one of the cool things. My wife texted me, and she goes, Dr. Yu asked Bernie personally to bring you over to your table while you were eating to introduce himself to you. I'm thinking, introduce himself to me? I need to introduce myself to him. You know what I mean? Like, this is
your goals. That was one of your goals going in. You're like, well, I really want to talk to Dr. Yu. I want to be able to, hopefully he'll give me the time of day. You didn't even have a chance for that.
Yeah. Dude, but totally off the charts. I'm like, dude, this is so awesome. And in person, dude, coolest guy could ever be, dude. You know what I mean? Come up, say hi to you. You know what I mean? Talk with you all the time. We had a good conversation about his theory. And the crazy thing is, man, his theory is right on with mine in a lot of ways. You know what I mean? And you don't realize it until you get over the finer points of what things are.
There's a lot of word jump. There's a lot of word mishmash. The words don't match. You know, so it's very easy to get caught up in this whole, this is not similar, you know, but it is, you know, it is. And he's a doctor, so, you know, and if I'm not mistaken, he was a physicist, worked for NASA, right? I mean, who the fuck am I to correct the gentleman in terms of the terminology being used? At the same exact time, there were things that I've heard him say in the past where I was like, he's right, even though he's like wrong. But in my opinion, which means nothing because I'm not a NASA physicist, he's saying magnetic, but realistically, for the purpose of being accurate and clarifying, is magnetic component.
Well, but he qualified it when we talked, man. And I asked him, I said, so what is a magnet to you? And I point blank asked him, I go, is it the same thing as I think? It's just a decay rate inside of a thing. So it's basically, radiation trapped inside there, but it's not harmful. And he said, yeah. Well, then now magnetism makes sense, right? If you think sheath zone, you think radiation, you think non-harmful, then you think it's magnetism. It all blends in there. And it went right along with how I see the theory of things. Once you get the energy level and the compression, all those things built out on a little scale, right? And then you just change one lower and one higher, one lower, one higher. That's the effect that you get with the energy and compression rate, right? So he was right there on board with that. You know what I mean? Because we talked about, ferromagnetic, paramagnetic, and diamagnetic, and how they work in tune with each other. And he was right on board with that. But that matches his theory completely in what they are.
So I mean, what's cool about it, though, if you think about it, right, is that magnetic component that he's talking about, it actually fits directly into, all my theory that I've been working on and developing, which is that, there's energy vectoring that exists, and anytime you have a rotational energy vectoring, you have a magnetic component, well, if you turn a current enough times, if you turn it enough times, it is therefore rotating. So a turning current, ultimately has a magnetic component. And then it builds up in geometry, which is the beautiful thing about it. And that's why it works with everything I'm saying too. And I'm not looking for things to work with what I'm saying. It just so happens to be this way. The difference between like experienced magnetism and these magnetic components, right, is the dimensionality of it and how it builds. So, if you just have a single point that's in a rotational state, it at that point is more or less like a one-dimensional magnetic component. But then if you bring more into it where it then has a forward motion, now you have a two-dimensional magnetic component. If you bring it into a vortex type form, okay, as it's moving, but it's also got a differential now over time, so it's got a fluctuation. Okay, now you have a three-dimensional magnetic component. You bring it to that next level where you have a center geometry to the tornado. You have a sphere with a central geometry. Now you have a four-dimensional magnetic component. And then you could keep building on the dimensions of the magnetic component. Mostly through field coupling and stuff, because then all of a sudden now you have one field that's 5 dimensions and another field that's 5 dimensions. The combination of both of them is not, it's the 5 that they both are plus the couple that they create, then plus 1, which is 11, right? So you have 5 on one, 5 on each side, but that's 5. And then you have 5 more that they are combined is 10. And then because they then combine again, they get that extra vector is 11. So you have an 11-dimensional field coupling, degree axis of freedom that exist within a couple. And that's the point.
I want to say that Ian out there is right in this. We were talking about things being bipolar, and I found this out the hard way. Shout out John Bigman for correcting me so many times on this. No matter how hard I try, that Tesla coil is not going to be, unipolar. It is going to be bipolar. Nothing I can do about it. So
I've been doing about that the entire time, and you could.
I know. I'm eating my words right now.
If you do away with the differential, if you only have one part that's relative to nothing, then you have nothing.
Right. Again, like I said, I want to eat my words right now. And John's been the one pointing it out. So I did it the hard way, man. My cap bank wouldn't work, and I'm flicking this thing, and you know what I mean? Something was just wrong, and then all of a sudden it started working, and the damn thing shot out on both ends, and I'm like, okay, there goes that conversation. I'm done. I got my proof, and I was wrong. So, yeah.
Remember the caveat, though. Remember the caveat, which is that it has to be bipolar, but there could be a polarity bias for certain.
That's absolutely what I called it.
Right. So when you squish one down, and then you have another one, what did you just create? You just created the same circumstances. That's the differentiating factor between positive and negative. You have a higher density, but under lower volume, right, on the bottom, and in a lower state of potential. You have a higher state of potential and a lower density on the top. These are the differentiating factors of these asymmetric systems. It doesn't matter pressure or positive and negative current biases, rotation, or or polarity. It doesn't fucking matter.
What it comes down to is how the negative is seen, right? And Sean found this out with his experiments as well. There's a buzz that goes on inside your wall when you start messing with a Tesla coil sometimes, okay? And, that's the negative saying hello, okay? Now, its frequency doesn't match anything that's going on in your box, so it's not harming it, right? But it's still there. So when you put it in the ground now gets some telluric current in it because now it's taking that energy and it's building out different spheres from it. So you have to really realize that. That's why they say so easily when you go into AI, it goes from a Tesla coil to a pump. Because as soon as you start recognizing that it gets telluric current in the ground, you realize it's a pump. It fools you because you plug it into the wall and you're not thinking about it. But as soon as you create your own ground, then you start to think about it and you start to understand the difference. So, it's a pump and then it's also a Tesla coil. But the amount of frequency, and you got to think about the distance and frequency you're talking about, we could be only talking about 2 or 3 wires that are going to that one side, which means that frequency is going to be super high, right? So you're not really thinking about that. You're just thinking about the frequency that's coming out the other end. So it makes a big difference in how you make these Tesla coils on which one's coming out where. But you're still getting some interference on the other side that you didn't realize it. And now that I do, I have to look at why it's pumping, right? And it's just like it's an ion pump. That's all it is. It's an ability to pull a vortex into the atmosphere that it pulls ions.
I'm the fucking worst, bro. Okay, I'm gonna just preface this with this. Now, so I hate to talk about AI in this conversation, okay, but like a lot of times when you're having these thoughts, God bless the fact that we're in this era where we could actually bounce things off of something, okay, that is going to probably, like, first of all, I'm talking about Claude specifically in the high model with the Opus 5. Okay, when you're dealing with Claude Opus 5 model, that fucker is going to push back at you every damn thing you say. Okay?
Yeah.
Every damn thing you say, it's going to tell you, it's never going to pat you on the back, and it's going to tell you why not every single time. And you know what? The government was using a version of this AI system, okay, for their own needs, okay, and for, you know, very explicit reasons, okay, it will not answer your questions, but it will not tell you it's incapable of telling you you're wrong when you're right, okay? Yeah. And it will try and tell you that you're wrong continuously based on standard models, okay? But if you sit there and you clarify, you dissect what they said piece by piece, and then you explain to it how it fits in and why not, it over time becomes receptive. It does not take your word for it either, because here's the problem, because I'm not going to say I have to lie to it, but I lie to it, you know. It sits there and it's like, okay, well, these are the tests you're going to run. Tell me the results. These are the measurements I want. And unfortunately, because A, I'm not set up doing the particular experiments like Sean is, right? Or you are, whatever, you know. And B, because, you know, we haven't really hammered down on the sensors yet, we don't have the data that it's asking for. Okay, so I just like kind of bullshit it just to move on with the conversation, because, by the way, Claude gets fucking mad at you if you don't answer its questions.
Yeah, you know, hold on, but
you don't answer its questions, right?
I shout out the person's name, but he likes anonymity, and that's he showed us how to take AI and convert it into something useful. That's not an agreement box or disagreement box. It's just a flat out, this is the way it is. If you program the AI to simply work on the numbers and the experiments and the math, right? And you eliminate the agreement, disagreement portion of the AI, and it's strictly something that gives you feedback on a parallel level that you're looking for, right? Which is the way all this data should come out in the first place. Okay? He showed us exactly how it was done, how it helped your system, what you're looking for, what to actually see if you can't find, okay? When you find it, you put in the data and it resets the system, okay? All of that information, man, he gave to us freely, and he showed us exactly how he's doing it, and he offered his help in doing all of it because he thinks it needs to get out there, and I 100% agree with him. So it's a whole new way of doing this, and I think when we start doing how to break down all the experiments that's going on with the devices that we're going to be doing with Richard, it's going to be a totally different game. It's no longer bias comes into it. It's a straight, clear, you know, flat out answer, which is something I really appreciate in it, because whether I think I'm right or not, I need a clear answer. You know what I mean? So, yeah, Ian was there. We did it in Ian's computer, and the algorithms, yeah, they're awesome. So, yeah, he knows who he is, man. Shout out to him. So that was pretty cool. And then, Ian, I want to get with you so we can get that thing hooked up with Richard, so you can get the program, and it'll just go along with all the stuff you already have. So I think it's totally awesome. And then he'll help you if there was something that you needed to add into it. We could just add it in there, and then you'd have it, and it would be awesome to see all the data coming out of it. Hey, I want to get a shout out to Dispatch over there, man. You come over today, hooked me up with some pizza, brother. He was there, you know what I mean, in case my wife needed anything when I was gone. So I appreciate the help, man. Thank you very much. Dispatch is an awesome guy. He's my neighbor out there, brother. One of the coolest guys in the world. So thank you, Dispatch, man. I really did appreciate that.
Right on, Paul.
So also, Ian's going to hook me up with some STL files, man. So Joe, every time I have these little probes going on over there for my oscilloscope, I'm over there taking a little bucket and I'm putting tape on it. You know what I mean? And Ian comes over to this nice, clean look. He's got this nice STL print, 3D print, and he's got it hooked in there with a little screw on the top. And I'm going, okay, now I feel like an idiot, right? So I asked Ian, I humbled myself and said, can I, please get the files? Dude's got some awesome stuff going on there, man. But just more professional setup, kind of, you know what I mean? Since we're doing everything else nice and clean, might as well have that as well. And I think that'll be a great addition, man. So.
Yeah, well, listen, I hate to ever sit there and, fluff someone up so much and mind the stepchildren while I'm at it, but, no, really, I mean, Ian's work is that clean. And, him and I have talked many times in the past, about just the intricacies of, some of the theories at play and sort of like, hey, what to expect here. And I mean, you want to talk about thorough, direct and to the point, and knows what the hell he's doing, knows what his direction is. I mean, that's the man right there. So, it's like I said, I'm so happy that he was able to go present, or have a booth that he was doing his own thing, and that you were able to get to meet him, because I mean, that's that a really awesome dynamic,
Oh yeah, he travels with all that stuff, Joe. He took he literally took his whole lab and brought it with him. I don't know if that's even his whole lab, but it looked like it. It would be my whole lab.
Given some of the pictures he sent me in the past, probably not. Seems like he's got it going on.
Yeah. It is crazy. You know what? It's one step closer to how we really understand energy, because we all use different words, right? Like electron, ion, things like that. Really, man, what we're dealing with is compression of energy. You know what I mean? That's really what it is. And then it builds out, and it's kind of hard to say because you see it once in a while, but you're not really paying attention to it because you never see a ball in there. You never see like a lot of vortexes. What you're going to see every time you look at energy is it looks like a fog. And it's a fog changing different colors and thicknesses. It's really what it is. So when you actually describe energy, if you're being 100% factual, it never use the word electron. It never use the word ion. Okay, you're looking at a pressure and temperature gradient is what you're looking at. Would explain probably everything in physics, you know what I mean, at a very fundamental level. But it's so hard for people to see that. So you have to bring them into it slowly. You know what I mean? Hey, there's this inside of this. You know what I mean?
Yeah. If you create a fluctuation on one side, that's going to immediately cause a bias, right? We know this, because that's what fluctuation does. Well, all of a sudden, if you have that then interacting with something that is receptive to it, aka something conductive, you're going to propagate that potential that it's stirring up, and it's going to travel to the capacitance line, which is deterministic of your pointing vector, realistically, and therefore your direction of propagation. So, it's super interesting when you have it kind of framed like that. It does explain why there's really no escape, right? In just let's back it up to like Mike does type of electrical engineering, which is limited at best. It's like from the electrician perspective, you have the current going down the line, right? And well, there's no loss realistically because of the propagation of the line. It's because of the resistance that it meets throughout the way, because it's not in a perfectly conductive state. So the loss is only because of the resistance, therefore the heat, right? Because impedance and hysteresis, therefore heat, are the thing, because energy directly interacting with matter in that fashion, high excitation is the cause of the thermal result, which is all built into my theory. Um, so that's the entire point, is that it's not really the conductivity of the wire, so to speak, in that case, right? It has everything to do with the interference that it's banging into along the way,
Yeah.
So if you're able to do away with the resistance, then you have no loss, and we know this.
Well, yeah, that's kind of
So,
the thing, though, isn't it? It's
right.
that. So when you had look at a high voltage line, they're not anything of what you'd normally use in your circuit, right? What is it, tension steel or something up there? You know what I mean? It makes no sense when you start doing circuitry, but then you look at it and you go, well, that makes all the sense in the world if the energy is going in line, but attracted to each other like this. Then you would start seeing the gaseous parts form until it thickens to the center and goes, right? Then you start
Right.
seeing it properly and you go, well, that makes a lot more sense when you start thinking about it in that manner versus little balls and circles and vortex. It just energy kind of together and goes.
Because it's
Yeah.
all moving, it's pushing and pulling, or just push, but whichever, it doesn't really matter. The whole entire point is that something's moving, and what comes in one end of the pipe comes out the other, provided that the pipe is full. And that's the problem, is that the pipe isn't full. That's where resistance exists. If you're looking at it from a hydrodynamic perspective, right? Pipe isn't full, so therefore that little tiny bit of unfilled pipe over an expanse, it ultimately kills the pressure, right? So if your pressure out of the gate is going to be maximum pressure, especially if you restrict it, which is what does that sound like? Well, yeah, I mean, and then if you're a step up transformer, right, through inductance. The idea is this, though, is the relative relationship between resistance and capacitance, right? Because that when you have something that's wildly conductive and high capacitance, there's very little resistance. But then there's also very low pressure, meaning low voltage.
Yeah. No. High voltage, low pressure.
Well, high voltage, but very low amperage, because
Right.
yeah.
Amperage is more your pressure.
Yeah. So, that just to kind of, to put that out there. So you have very little loss in that circumstance is the point, right? But the
Well,
usability.
let me throw this out there for everybody so that if they've ever seen this experiment, they can understand it finally. The sticky bud experiment, right? So it looks just like static electricity, is what people say, and you convert it. One of the things they miss in the beginning is the swirling of the wire. So just understand this. When they take that wire and they come it off and then they swirl it, right? That's the first sign that they're changing the energy. They've already put in there a value so that it can't go back. That's their diode in the system. And then they get over to this one thing right next. It's called the capacitor thing, and it's shells, right? It's a sphere inside of a sphere inside of a sphere. It's resonant shells. As soon as you put it in there, it's not so much converting the energy as it's enhancing the backstop. Okay. Then you get over to the next part, and they have the U-shaped magnet, right? And you have to start thinking MEG, MEG. Okay. If you don't have that in your mind, it's going to be very hard because you're moving flux. You're basically taking the magnetics and shifting it back and forth in oscillation. So you're not still dealing with a whole lot of stuff, but you're using a lot of different electrical tricks in order to get this energy right. Okay. It's a conversion without using a bunch of capacitors. Okay. It's running into a capacitor is like running into a wall. Okay. And you don't want to do that right away. You want to slowly get that energy to move and then shift. Okay. And that's what they're doing in that experiment. It's high voltage. Okay. It's static electricity, and it's very low amperage. It's what everybody says is a waste because they don't know how to convert it. But the most powerful thing you can learn is the conversion rate and how that's supposed to happen. And once you do that, the game's over, dude. Free energy becomes easy as you can ever believe. You know what I mean?
you just repeat the process on the conversion to what we just said, you separate your heat and your cold, then all of a sudden you have high efficiency. It immediately would fall into resonance under that circumstance, and then you would have almost lossless conversion. So, that's the thing. Oh, anyway, by the way, something weird happened this week, man. Something weird.
Go ahead.
All right, well, I got an Amazon package, right?
Oh,
And
yeah.
I didn't order anything, and somebody sent me a handheld Tesla coil, not the face buzzer. Okay, an actual handheld Tesla coil. Don't know who it is. Wasn't you? That was the only person I could think of. You're the only person that knows where I live. But it's probably my ex-wife. But so they sent it to me. Okay, now it's very light in here, so I mean, probably can't see the discharge, but when I tell you it got some zap. Now, I did something absolutely fucking retarded. Okay.
Okay. Oh, it starts good.
And I don't know that I ought to do this because I don't know that I can show it properly without like kind of hurting myself. I don't know. I'll try. Move some shit over on my desk. Okay. So I had a spool of solder. Okay. And I took the spool of solder and then I had a shaker ball. Okay. And I made sure that the rotation was the same as this guy. All right, and then I had like a little diamond tipped like Dremel bit that I kind of just fitted into the middle of it.
Mm-hmm.
And this thing puts out a massive fucking EMP that like it not only messes with every goddamn electronic signal in my entire, I don't know what the reach is, but it feels like it's significant. Okay. But like I could sense it. I could sense. I'm like, ugh. That thing's throwing out some. It's chucking the goods, man. It's chucking the goods. But
nice.
I mean, I will attempt to show you guys. Hold on. Let's see. Where are we? Look, little bowl right there. Messy desk. Don't mind that. All right. Let's insert this little dick into the female part there. All right, and I'm gonna reluctantly hit this button. Oh, that is so noxious. I feel that right away. The fact that
well, you have a giant antenna there.
Yeah, I gotta let it build up a little, maybe. When I hit it last time before, though, man, it messed with everything. It's messing with nothing right now, so that's probably a good thing. I mean, I could feel, I gotta back up from it, man. Yeah. All right. Yeah. So there's probably some radiation coming off of there, and probably X-rays if I had to guess. So I'm not really sure, but that's the deal.
You try to melt the solder with a tip?
It doesn't.
It doesn't melt?
No. In fact, look, I mean, it's powerful, but it's very high voltage and very, very, very low amperage. You could feel that more than the other thing, but
Oh, that's all right.
Not super significantly. Now, I inadvertently touched this thing with my left hand. I got a piece of titanium pin in my wrist, and I don't know what it did to the titanium in my wrist, but I could feel exactly where the pin was, and the whole entire thing was numb for fucking I don't know, hours. It was numb for hours. So I have no idea what it did to that titanium, but it did more than nothing, and that was strange. And yeah, I don't know how many volts, because it's probably a lot.
Wow.
It's probably a lot, because
Yeah.
you got the coil in this thing in the first place, right?
Yeah, look at that.
Then
That takes some time.
That's a coil.
Yeah.
And then it's going to an entire spool of solder.
Well, hold on. You're not even connected, are you? Hold on.
No.
The tip's not connected to that at all.
No.
What's in there?
Oh,
it's just a spot.
Screen. Not
So hold on,
surprising.
let's see the other side. That's not even.
No,
Wow.
no. It probably arcs about a little more than a quarter of an inch. Arcs about
Huh.
a quarter of an inch from that thing to hit the bottom of this.
Wow, somebody took their time and learned some lessons of Tesla coils and sent it to you, man. That's awesome.
Yep, I'm having fun with it. I've been dicking around with it all week.
Nice. I love it, man. I still remember Sean got me the first time, man, with that damn thing. I put it through my hair, zapped the living daylights out of me, man. Oh, he knew it was going to do too, so he got a great laugh out of it, which is even better.
And I mean, and listen, this acts just like a big Tesla coil
Hmm?
in the sense that capacitance has a lot to do with the energy out.
Oh yeah.
Big capacitance on whatever's receiving it within its range of the field, and it's gonna light up like real nice. You do away with the capacitance, it's gonna dim out, which should tell you everything you need to know about you.
Yeah.
Not about this, but about you. Because guess what's lighting that motherfucking light bulb mostly at that point?
Oh,
You.
nice.
That's it.
Oh man. That's so great. I love it, man. When people send you stuff like that and it just works. That's awesome.
Yeah. Knock your third eye with it a little bit, you know. Ah, oh, son of a bitch. Oh, look at that, wide open.
What is wrong with us, man? I don't think anybody can avoid not doing that. You know what I mean? Like, how does it hurt? Let's see. You know what I mean?
It doesn't hurt that bad. But you know what though? Like, come on, with all the quartz that I have around here, I've been wrapping quartz and everything. I'm like, all right, you just jack the voltage way up, and then just get it to. Yo, I had a piece of like I didn't notice it while it was going on, and then I stopped, and then I hit it again, and then I pulled this thing well away from it, and I was like, wait a second, it didn't sound like that a second ago. That's because the piece of quartz was fucking screaming. But yeah, that's a whole nother story for another day, I guess. I couldn't get it. It doesn't have enough power to get it to tribo though. So
We're gonna have to get you a little cheap frequency generator, Joe, and a piezo disc, so that you can connect it to all your pieces of quartz and find the frequency of each side of it. You know what I mean? That would be cool. See, here's the thing: if we can get a Tesla coil to go down in the hertz, like really good, then we can start playing with some quartz here in the right way. And here's the thing: you don't have to do anything to the quartz except for know the frequency of it. And then once you know the frequency of it, now you can take your Tesla coil and build the resonance to that frequency. And then you can start messing with the quartz, making it vibrate, turn on by itself, everything else. Because
so the cool thing
works on
about
the frequency.
if you actually cut the quartz on an axis, change the frequency of the point of interaction. So when you manipulate the lattice in that way, it creates a gradient, right? And that gradient isn't its natural crystal structure. So its frequency therefore then fluctuates in relation to the angle cut against the lattice. That's how they make tunable radios, right? Is that you have to be able to have a broadband cut to be able to be capable of this gradient of frequencies throughout the lattice structure, depending on where in the quartz it's tuning into. And that's how they used to be able to receive and transmit radio signals, right? Well, long story short with it, if you make the same type of cut, and then you pick a side and a frequency, but then you make an opposite cut on the other side, and you create two excitation points with the frequency driven through it in resonance, you're going to create the low beat frequency in the lattice structure, which would still be in resonance with the lattice structure itself because of the nature. So if you want a low frequency, that's sort of probably a way to attain it. I just haven't thought about it until this very moment, so it's not developed. This is not a developed. But
that's what I mean. The little frequency generator and a piezo, you get your answer, you get all the numbers you need, Then you start playing with it.
Right.
So, yeah, because that, you know, as much as you're putting high energy in, it works great and it looks nice. The secret to any kind of crystal is, can you match the frequency with something else to get it to oscillate on its own? And that's genius.
Once you get it to oscillate on its own, that's the difference between the constructive interference and the deconstructive. And when you're talking about something that inherently creates a current potential, a current potential, as a byproduct of its excitation, like now you've unlocked something, and I think that's pretty key. But you saw the piece of quartz that I blew to pieces, but I got the plasma inside of it. But it was deconstructive plasma, and it resulted in exactly what you would expect from deconstructive interference.
Because it's starting to balance the frequency and harmonics, but it's ultimately destructive in the way that it comes out as a plasma. Yeah.
Correct.
That's the key.
And the thing about constructive and deconstructive interference, and this is another talking point that I have with Claude, where I was like, here, you want to eat your fucking words real quick? I'll make you eat your words, and you're going to like the way it tastes. Because, the deal with constructive and deconstructive interference is that you can't have one without the other. Thomas Bearden said one time, right? Well, you have to destroy part of a waveform in order for it to interfere constructively, right? At the constructive interference nodular points. And the thing is that all the energy that came from the deconstructive interference ends up at the constructive interference points equally, without resistance, and how fast? Instantly. No matter where in the waveform it is. So, what does that mean? That means that you have this process that occurs, okay, where you must have two ends to the process. It must be destroyed somewhere for it to be amplified somewhere else. And regardless of the distance, that process is going to occur simultaneously.
I don't know that you need to destroy it, but you need to reduce it.
It's not destroyed, it's moved from here to there. It's trying to say it's not moved from here to there. I'm like, so where the fuck's it come from?
Yeah. Exactly. I mean, you can move it, yeah. Destroy it. I don't know if that works.
Well, hold on. Now, what happens if you have a constructive interference event in a wave interference point of interaction? Okay, before the deconstructive occurs, based on the time of initiation and propagation and the points of intersection. Okay. Nah.
No. It depends on the. I don't know what's going on with this mic. It depends on the frequency that's going on in them, because they'll pass like two ships in the night, won't even see each other if they're the wrong frequency, which may be the case that's going on. It's going to cause a different thing to happen in the system, but it won't, interfere in any way with the constructive part, if that's the case.
Right. So, but what's that mean? It means that it's retrocausal. And if you recall what I've said about RAV, there's aspects of it that appear based on observation, and unfortunately not measured yet, but we will get there. Okay, hopefully, that appear to be retrocausal. And when you and then when you map out the whole 369 vortex math, right? And then you reduce the dimensionality of it, okay, to a graph, as opposed to, a circular graph, which is like kind of two-dimensional, right? If you just, no. So I guess it's three-dimensional. If you put it on a two-dimensional graph as opposed to a three-dimensional graph, okay, at that point, what you see is that the initial sequence of the pattern in precession is retrocausal as well, because what you end up with is a 6 trigger, okay, and to the 9 before the 3 trigger occurs. So there's a retrocausal action that occurs in that reduced dimensional graph.
Okay.
Yeah, and that's the same thing that I'm describing here. You know, when you map these wave interference patterns, you could have a constructive interference event before the deconstructive one occurred at some point that did not occur yet. Even if it's only, milliseconds in the future, still, it did not occur yet.
Interesting. It's like throwing an off wave out there, just out of the blue. You know what I mean? But it's got to be accounted for. So then, when you account for it, you find out where it came from. Kind of like when we get earthquakes. Every once in a while, you get an off frequency, and boom, it zooms right to the planet, and here we go shaking.
So hey, what happens if, silly thing, what happens if you allow your constructive interference to occur? Okay, but then you kill it. You kill the waveform before the second interaction.
Okay. I don't know. I've never done it.
Well, it would be, it could be done with the circuit, right? Because you could do it based off of a switch. So if you knew exactly what the interfering frequencies were, okay, and then you have it tuned to exactly that, and you knew where they were going to occur, and they were slightly out of phase until that amplification event, until that one point, and then they were triggered to shut off immediately after that particular duration, then you would have would you? That's the question. Would you have your constructive interference event without the deconstructive? Yeah. You see, I don't know for that, because if it's retrocausal and one needs the other, there you go. Right? But if you could potentially just create a constructive interference event without a deconstructive, then you just broke, the whole law is the problem. See the problem?
Yeah. Well, I don't know that you don't need that, man. I mean, we just need a high efficiency rate for what we're doing. We don't need things to be perfect.
Agree. The separation of hot and cold is that in itself. So
yeah,
in my opinion, it's already achieved and not measured. That's my opinion, but yet to be seen.
Yeah. We have to look into that more. So I don't know if you guys can see it, but behind me back there is Sean's devices. I just got back yesterday to get into work on them. I ran all the cables out there. You can see that probably. It's that shoulder right over there. All the cables and stuff are run. They're ready to go. I just got to connect in the connectors on the end, which should about an hour's worth of work. I just wanted to make sure that I looked it over one more time before we fire it up, so I make sure the positive and negatives are right. You know what I mean? And then which ones would everywhere based on all the schematics that I drew for them. And then that's done. It gets shipped out to Sean, and then mine will be done right after that. I got some wires to put together. I'm hoping on Saturday to have most of that done. I want to start testing here this week. And then it's going to be, highs and lows until we get it perfected. One thing I need to get with Richard on is I need to order a motor driver from Amazon for my Gravity Flyer. And the reason for that is I need to get the frequency off of it, because everything that I put over there in high voltage gets zapped. So I can't exactly use that by the disc. So it's something we talked about before, but I'll have to do that. That won't be that hard. That should be fairly easy. We'll just throw it in the update, you know what I mean? And then hook it in with the little Arduino and it's done. And then the oscilloscope works on the same way that we hooked it into an Arduino and do it. I had a spare Arduino here to do it, and I did it. So that works on the oscilloscope portion. A lot of cool things, man. So hopefully we'll nail down the rest of those, and we'll be doing that on the experiment. The Bedini device, like I said, I have 2 extra coils sitting here at the house. I should have 3. We're going to hook that up. I'm going to buy some MOSFETs and we're going to start to look at some of the things on that, on how to get the extra energy in it. I do agree with Joe on the RAV thing, though. That has to be presented at Tesla Tech at some point. I'd prefer to have the team there to present it as a single unit. You know what I mean? All of us up there. I think that'd be the way to do it. We all see it in a different perspective, but each perspective is valuable in what it is. That's kind of the moment I'd like to have with it. Some of the other stuff is, you know what I mean, is work, get it done, get an answer, right? You know what I mean? And it's pretty straightforward when you get to it. It's just getting it through people's heads on what we're doing. But I think the RAV's mind blowing, so it has to be taken from different perspectives. You know what I mean? As you see it. And then the one thing that we have to nail down out of anything else is the how do you see it? What's the camera actually doing? Where we can compare it to every single camera effect to show it, because that never is going to go away. That has to be addressed up front. You know what I mean? Right in focus. Get rid of the naysayers right out of the group and just start hitting this thing home. And then we can go into all the greatest effects of it all together. But I don't think it happens without it.
Yeah, I mean, we definitely, I agree with you, by the way. And the thing is like, it's a bit of a strategic choice, you know? Like, there's got to be like this, yeah, it's got to get out there because it's kind of like the most inclusive thing, right? So in it, you can see all of the phenomena that we would hope and expect. Like, no matter what the phenomena is that anybody else there is presenting, it is inclusive in that. Now, we need to show at least one in action, proven and measured, you know, and then with a demonstration for it to be effective. And then the implications of the rest can fall into place, right? But without showing one with the, like, you know, beyond, you know, speculative proof, right? Then that's it. So long as we could show one thing, whichever one it is, it doesn't matter. Objectively, then it's the biggest slam dunk that's ever occurred. You know, and
I think that starts with the rotational one, Joe. I mean, we have to show the rotational one so that you can see that we have some, you know, working inside of it while it's in motion, because camera effects go this way. They don't go rotationally, okay? And that's the biggest dispeller of all of this, you know, on what the camera effect actually is to see it rotating and you just go, oh, hands up, we're done. We can see that there's structure there.
So the whole thing about the camera effect is this, man. It's relative perspective, okay? And it's a projection. And the problem with it is that it is the same as a lens flare. So the blessing is the curse, you see? Because it is the same as a lens flare, but it's showing you exactly what it is in a upper dimensional projection into our, however much is permeating our reality of in phase with our dimensional observation. Okay, so the biggest question that I posed would, because Sean had asked me a whole lot of questions and he brought up the flare a bunch of times, and you know, in that I said to him, and it was very important, I was like, is the flare there? Yes. But is the flare here? That's hard to say. You see, and we can have we could have partial relative permeability, okay, of the flare event that's exposed via the observer point and relative to the observer point. Okay, but that does not necessarily mean that that acts as an access point. See, the access point is always going to be the what's physically here, and that doesn't mean that it can't have environmental interaction or consequence that's observable here. It just means that it's not necessarily attainable here. The reason that it would be observable here is because of the permeation. So whatever amount of that upper dimensional geometry is crossing into our in-phase geometry, okay, is what we are able to perceive as, what we observe, and it's only relative from the point of emission and the point of observation, okay? The thing is that doesn't act necessarily as an access point. And it could have electromagnetic upper dimensional effect on the environment, okay, without us necessarily being able to tap into it. So that was sort of a thing, because he asked me, like, if this is here and this isn't, then what's going on? He asked me if every time the flare is present, does that mean that the anti-flare, the dark spot, is present? And I was like, present. Loaded question. I was like, is it there? Yes. Is it here? Possibly. Depending on the degree of permeation. So how much of that 4-dimensional geometry has crossed into phase? That's the question, right? Because that's the contingency of what your observation is. The thing is just because it crosses in does not mean that you can interact. And here's the analogy, okay? You are a person and you have a piece of paper and a pencil, okay? You draw on a piece of paper with the pencil, okay? And that piece of paper, okay, if it was able to be an observer, okay, could not see you because you are not in its dimensional plane. You are not crossing into its dimensional plane. Now, if the pencil touches the surface, okay, it would not see the pencil and it would not see you, but it would see the manifestation, okay, of whatever the pencil chooses to do. Now, you could take that piece of paper and you could crumple it up into a ball and you could throw it across the room, okay, and that everything on that piece of paper would be none the wiser except for the effect that you've caused on it. However, nothing on that piece of paper can interact with you, period. Hard stop. It cannot affect you, you can affect it. And that's it. And that's how dimensions work. See, you could affect every dimension lower than you, but you cannot affect the dimensions higher than you. And then the amount of effect that you have is limited to whatever you're doing, as you cross through that. And that's the story. So, like, if we see it, right, that's just a projection into our phase. Okay, but we only have a small cross-section of whatever's going on at any given time. And we can't necessarily interact with it, even if it could influence our environment. So it may have environmental effects on us that we can observe, but we cannot necessarily tap into it. Does that make sense?
Yeah, kind of.
Right? A piece of paper can't fuck with us, right? The drawing on the piece of paper can't fuck with us, but we can fuck with it. Same exact story.
I don't know that it's in. How do I say this? If you see it on the screen, it's within reach of manipulation. Is my thought on it. When you're not seeing it, and then it's manipulating the environment, that's when I think it takes a different dimension. So I think if you see the little black dot in there, it is an exchange in the dimension we're in. Now, it may have another repercussion outside the dimension, okay? But it's still, you could, because if the energy changes in the center point, okay, of the RAV, it's going to change that energy in that dot, right? So in this dimension, it could be manipulated, but it may have an extension to another dimension we're not in, right? So we're able to manipulate it here, and we see it here, but what it's actually doing.
But it's not it does.
Okay, I'm just saying. I'm trying to get my head around it.
Stepping up and stepping down process is the thing.
Okay.
It's awesome. It's really intriguing. It's not the hardest thing to understand if you understand the analogy, right? The whole thing is that just because it isn't doesn't mean it can't be, because here's my theory, okay, and you do with it as you may. The portal lies at the Planck scale, and we have to understand this, okay? And when you reach a certain level of high excitation, okay, there's the resistance barrier drops, okay? Because here's the fucked up thing, and here's where the misconception is, and it's dimensionally relative once again, okay? They'll tell you that heat, okay, is an increase in resistance. However, when you take my theory in my paper, okay, into account, and you realize that the high thermal, is the byproduct of the high excitation of an increased exchange rate dimensionally, okay, you realize that it increases the exchange rate, reduces the resistance, okay, and the byproduct is shoved to the side as the byproduct. Okay, it's only when the heat remains in your system, okay, that it acts as a resistance. So heating just because you have heat doesn't mean that you have increased resistance. It's actually a thermal signature of the reduction of the resistance, as long as what? As long as you keep your high energy state and your low energy state separate of one another. And
Okay, hold on. I don't know that I agree with a certain part in there. As soon as you have heat, you have resistance because it makes light.
Sure it does. But again, byproduct. It's all falling within spectrum of Planck. If you're saying light, it falls in spectrum of Planck. It makes light, it makes heat, and that's
light's outside of Planck. Light can't propagate inside Planck.
Light is manifest only within Planck.
No, outside of Planck.
All along, which is my argument all along.
No. You have superconductivity. There's no impedance there. There's no light. Light's outside Planck's distance.
Natively, it is absolutely.
I don't think it's inside of it at all. Hey, let me real quick before we argue about this for a while. I want to shout out right here, Greg from Tesla Tech, man. Thank you very much, brother, for checking us out, man. That's what we do here, man. Appreciate the fact that I meet you in person, man. Right on. So, sorry, Joe. I know we're going back and forth on this, but I look at Planck as the very high frequency, high voltage state, and there's no light there. There isn't. It's outside of it on the shell.
The threshold. It's a threshold on both sides. You see? So it's threshold on both sides. So you have high excitation, okay, leaves phase relevance to our dimensional phase, okay? As that matter then returns to the higher dimensional energy state by virtue of energy, again, the result is thermal, okay? And so long as the thermal is kept off of your conductivity and separate of the low energy state, okay, which allows for the exchange, and then the resonance reduces the resistance, okay? That's the exact theory of RAV, is the point, right? That's the exact RAV theory. It's just in play in a different application.
Real quick, Joe, what's that thing where they take a piece of paper and they flip it on each other, and then they tape it together, where it has a continuous song that it would play backward and forward? What do they call that? Do you remember?
Play a piece of paper that they tape.
A flat piece of paper. You twist it like a figure eight, and you tape it back. Mobius strip. That's what the energy exchange is. It's never crossing each other. It's a Mobius strip.
There's no disagreement there, because it is by virtue of the flip in polarity, okay, at multiple points, okay, that allows for the symmetry that's still asymmetric in its exchange, right? Because the whole deal is that, you know, to induce the high energy state, okay, but leave the low energy state behind. We've observed this. This is RAV. You've seen the snow, right, as Sean likes to call it, right? The fractal snow. Well, the fractal snow is a very, very, very low energy state. It's because it's material that had its high energy state fucking stripped from it, shoved to the side, separated, in for recombination. There's thermal event occurring in all these circumstances. The thermal event is controlled and displaced because it's acting as Maxwell's demon, you know? So who gets through the door and how much is, you know, determinant based on the, you know, the broken K value of your dielectric condition, which, by the way, not dielectric material, your dielectric condition, okay, which is important because as Sean has shown, it doesn't need to be a dielectric material. It just needs to be a dielectric condition. You know, so even if it's a conductor, okay, if you have enough resistance in between it via air or whatever, there's still going to be a controlled exchange, and it's still going to destroy and structure your conductor, okay, into a low resistance metamaterial. Whoa. You know,
Well, you learn that. You learn that in how a transistor works. As soon as you know how a transistor works, you already knew that. Yeah, exactly.
Right. It doesn't need exactly the arc is a part of it, but there's a lot of energy that's not in the arc that's coming off just as you know, transient energy that in a directional propagation that's being you know, inducted into the material itself.
The arc's a bad thing.
More holistically than the arc, because the arc is a point of contact.
Yeah, the arc is sometimes a bad thing. You got to understand that, especially if you deal in low energy. You get a spark, you fry everything. You know what I mean? Once you realize that, you realize why the lightning bolts coming out of our sky is a discharge. You know what I mean? Too much energy in the actual capacitor, so it discharges itself. So shout out Mike over there at Faraday Research. What's up, brother? Oh man, yeah, that's kind of crazy.
Been a minute, brother. We got to get back on there and break everybody's balls a little bit, because that's what we do best.
Well, when you think about this. You get the cold weather, right? And it's taking your atmosphere and it's bringing it into a really super cold state. So the energy increases in its value up there, and then it can no longer hold itself. So then it has to strike out with lightning bolts into the ground in order to discharge itself. I mean, you just took a thermal, you know what I mean, to put it into an energy state, and the energy state just erupted and created lightning bolts. I mean, if you understand how that just works right there, your temperature in your system when you're doing your energy matters a whole lot, and it'll change completely. I do this in electronic systems. I listen for the sounds in it, right? And I put a bunch of the things on there with my oscilloscope, and I'm trying to figure out exactly where it goes awry. Okay, what heat did you put into it? What did it change the frequency? What's going on? How do I make the circuit more effective? This is, by the way, why my circuits run all the time, and everybody else blows up their circuits, because I figured it out. You know what I mean? When you're dealing with this stuff, a rogue temperature can cause a rogue frequency that goes on, right? So when you say, okay, I need to take a diode, I need to put a capacitor above it. Why? Because you're killing the rogue frequency. You're not changing the value. You're killing the frequency that goes on in there. So then your system runs better. But this is why a lot of people fail in supercomputing, because they don't understand this. You know what I mean? They're understanding it in a very atypical fashion of, you know what I mean, this converts over to this, you know what I mean? This over here has to, you know, get so big in energy levels for its transfer, but you're not realizing what's actually going on. Like, you don't realize your resistors creating heat. You don't realize, you know what I mean? There's different ways to do things. So if you put your resistors into a system, or you put diodes into a system, and you're not realizing the drop in energy and the frequency difference, you're going to think that they're magical and special, when I already know that they're not. You know what I mean? They're just a value that you didn't really put in there because you didn't know it changed your system. But it could take your lights from super bright down to super dim in a second when you're dealing with high frequency in systems, because it matters how much temperature you have sitting in that thing. As soon as you create heat, you kill it. You absolutely kill it.
So here's the crazy shit about it, about this exchange in general, and this is a quiet part out loud, something that we haven't said, but the asymmetric exchange, if you're thinking about it from a thermal perspective, okay, you need more high excitation thermal than you do cold, okay, because it takes more of the high excitation thermal to bring that low energy state back up to a medium, okay, than it does inversely, okay, which means that you're, and entropy doesn't like this, okay, but basically you're spending a whole lot of this thermal energy just to bring something back up to the same ambient state of excitation, okay, then you stripped from it in the first place. And that's the thing. It costs more to bring it back up to that ambient level, okay, than it does, okay, to strip it. That's your gain. And if you don't see it, then I don't know what to tell you.
But that's what goes on in space, doesn't it? When you start talking about photons and stuff in space.
That's why they, well, and I said that it's not in line with entropy, but it kind of is, because what they're saying is that the low entropic state, the equilibrium state, which is very low entropy, is basically all your thermal just completely dissolved in a sea of low excitation. So just right off the bat, you have a lot more low excitation than you do high excitation. So when you're talking about the ratio and you're talking about what it takes, right? It doesn't take much to break the bond of the excitation to bring and strip that whatever excitation it has in the break of the bond plus whatever energy was spent and put it on one side. And your separate reduces your resistance. And then on the exchange of the recombination, it's going to take a lot more of that thermal, okay, to bring that back up to ambient. So you're just surplusing your low energy state on one side, which is why you physically see a condensation of the low energy state in a structured pattern, is because it's in excess.
Okay, hold on.
If that was the one that was exhausting faster, then you would not have the surplus.
Okay, hold on, Joe. Which one is the high energy state and the low energy state to you?
Well, your high energy state is when you break it and you take your your electron, okay, and then you're putting that on one side, and then you have all your ionized matter on the other side. And your ionized matter is in a low energy state.
So let me ask this: if we're in space and say the sun, pulses, okay, and it hits a rock out there, and then the rock turns on some light, right? And you get some thermal going on there. Is the rock the high energy state where the light can be seen, or is the background the high energy state?
Well, the high energy state in that case is based off of kinetic energy and the interaction between objects. So you have the two high energy states that are ambient to themselves, but together with their kinetic forces combined, okay, are in excess of the high energy state of either combined. Right, so that's mass and velocity, right? So because of the velocity and the kinetic state, there's more than it holds in onto itself on both sides, and that's spent, and that's still entropic in its nature. And your light event is from the high excitation of the combination of two, which would reduce the velocity of at minimum one, probably two. And also change trajectory.
Okay, so
it's a dynamic relationship.
Here's the way I see it, because I've seen it done, in the RAV when we did it, and I have video of it. You see this, the RAV bursts out, and then it goes on and hits a little point, and there's several of them, and then they bust out with light, right? So the point where they put out the light is the low energy state. It's a state with loss. The high energy state is the area in between. There's no loss going in between there. Okay. It goes without loss. So it has to be the higher energy state. It's confusing because physics gets it backwards. They say that the heat state is the high energy state, right? And that the low energy state is where you can't see the light, right? But that doesn't make any sense because the energy itself isn't being used in the dark portion. It is being used when it hits interference, right? So as soon as you hit the interference and it's putting pressure back against it, that's how you get your photon, right? So that has to be the lower energy state because it's expelling energy out of it from the higher energy state. It's no longer in rhythm with the higher energy state, so therefore it's throwing out energy. That's kind of the way I see it. So, but
okay, so physics proven, right? If you bombard manifest photons. Aha! What did I say? Manifest. Non-transient photons, okay? Meaning that they're already in a collapse state, all right? And you bombard the collapse high density photons, okay, with gamma radiation, you create particulate out of two kinds of radiation based on those the sum of those collisions. And the nature of that is that because of the interference, okay, and the collision itself, okay, you've effectively created a high energy density state, okay, that has then reduced itself in frequency to the point of being particulate. Interesting, isn't it?
okay.
So the whole point is that we know that the kinetics have what to do with it. Kinetics is the most fundamental of observable physics. It's what you learn in, this is the first physics that you learn, equal opposite reaction, right? That has everything to do with kinetics. So when you take kinetics and then you apply it to, wave dynamics, because it still applies, because the interactions still occur. You have these circumstances where, you have these excess energies. There's a splitting, there's a light event, but when it collapses back down, okay, because it comes back onto the side, it exits and then re-enters this side of the Planck scale, and when it does so, okay, it comes down in its frequency, period.
Yeah, that's what I'm trying to say. The frequency way down, so the energy levels.
Is that it has to, when this collision occurs, okay, it has to break, and then when it breaks, that's so much energy that it falls off of the Planck scale, but then it re-enters the Planck scale to recombine, and during that collision recombination event, its frequency has went from light spectrum and gamma spectrum to material spectrum frequency. You see, because but where did that, you see, that's what I'm saying, is all that energy had to combine back down, but its frequency dropped, so now you have a higher density particulate. And this isn't me making this shit up. I mean, this is the way it goes. If you bombard photons with gamma radiation, that is effectively the result at high energy states.
Interesting. Yeah, I see it different than physics. I see it backwards, and it's just based on
what you're thinking is exactly actually the way it goes. It's just that you can't ignore the process. That's all.
Gotcha. Well, it goes to why I don't like vacuum chambers, because you suck out everything special instead of transforming it and understanding the process. And this depends on the viscosity of the energy in the system. So it really becomes a problem if you don't see it right going to the next level, because you'll never get anywhere. You'll just be in an infinite loop of stupidness, and it won't allow you to move forward. You know what I mean? You have to see it the right way. Like that's why somebody, when they talk about the entry pump and they're just talking about its great directionality, well, that's an oversimplification of the wrong thing. You have to use the temperature differential in order to see it. And if you start talking about just directionality, you miss the point. The point is that you get to the finite small part of the equation where the magic happens, and the magic is not happening where you're saying it is. It's happening over here, and then you must qualify it that way every time you say it. That way, the people see it right. You know what I mean? Or else they'll go around, they'll throw different things at you. They'll start talking about magnets and crap, and then before you know it, you're building this magnet trap that's absolutely completely useless. It's a doorstop. You know what I mean? That attracts garbage. That's all it is.
Nathan, I couldn't agree with you more. And the biggest problem with this is that you have two true things on opposite sides of a wall with no door. And you have relativity and you have quantum physics, and you have one here, one there, and you know that they're connected, but nobody wants to talk about how. And until you bridge that gap, you're just going to be sitting there requiring measurements for empirical data, requiring observation for empirical data, okay, but looking at it from the wrong point to capture the data. So you will never, ever, 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 ever solve that problem with those constraints in play. Okay, until you acknowledge that it's possible, right, for there to be a bridged gap, okay, and then to sit there and speculate what that bridge gap may be to understand how to actually maybe possibly create a circumstance where you could take a measure on the other side of the wall. It's dead. All this shit is dead on arrival because of that reason. And that's it. It requires empirical data, it requires measure, it requires observation, but yet it's not here to be seen. So then the only solution that we accept is that the math says what that is, and the math says what this is, and these are two different things altogether.
So hold on, Joe.
You will never find the mechanism if you don't find the door.
Hold on. Let me get something straight here so people understand this. This is why they don't understand Einstein-Rosen bridges. If you're in a bubble environment, okay, and you have two bubbles, okay, and I want to create a bridge between the two. It's kind of like a pool. So you go outside, you go to your pool, you put your hand in it, go like this, creates a vortex on one side and opens up as a vortex on the other. Same concept as an Einstein-Rosen bridge. If you see your solar system as a bubble, and you see the same bubble over here, okay, you're just moving your hand in between them. That's it. You're creating the conditions so that you can do this. You're creating that pressure. You're creating that little wormhole. Okay, that's it. And if you don't start seeing it as this is a, full pressurized bubble and this is a full pressurized bubble, you'll never understand why it works. Okay, it'll elude you forever. But you can get it. You know what I mean? As soon as you understand why the vortex works.
I'm going to play with your analogy a little bit because it's a little bit stranger than that. If you have your pool, okay, but you have a piece of, plexiglass under the surface, and then you have your two bubbles and they're one on top of the other, okay? In order for you to go from one bubble to the other, okay, you have to go all the way here and around the plexiglass to the bottom where the other bubble is directly underneath you. You can't pass through the plexiglass to get to the bubble, okay? But if you were from the top perspective, all you see is two bubbles, one on top of the other, okay? And, because you're outside of the circumstance of the threshold of the water, okay, this doesn't apply in reality, but for the purpose of this example, right? Propose that you'd be able to go straight from one bubble to the next through the fucking piece of plexiglass because you're looking at it from that exact upper perspective, not in that environment. And that's actually kind of what it is. So you got to go from point A to point B in that situation. But once you're out of the water and you're looking at it from above, you just go right through, and that's sort of the difference, and if you think about it as something that can actually penetrate the whatever, like, because it's a plane, the plexiglass in this example, if you were to shoot a bullet, the bullet would have to go and then travel around to hit it. But actually, in all actuality, you'd have to travel around the Earth and then,
I don't know if I buy into all that.
Oh, you can go bang.
Look, it's as simple as this. The higher energy state in the RAV is the black dot. The black dot, like you said, is here and there. So where is it there? We know that it's here. Where is it there? That's the thing. That's the Einstein-Rosen bridge. That's the high energy state making the Rosen bridge over to the other bubble. That's what's going on. There's an exit point inside of a pressurized zone where it goes. That's the problem when you start looking at physics. When you want to create an Einstein-Rosen bridge, you must first structure it in both ways. It must structure to it and back. And you're going to have to create that equilibrium in order to do it. Failing to do that will just instantly crush you and turn you into light, and you'll be garbage. Yeah, understanding how time differential works in that is a big part of the equation, because if you do not dilate the time, you cannot get it right, because the time is what's opening the hole. Okay? That time dilation is directly affected to how you're opening the hole to make the Rosen bridge to move it over. And it's more than just directional states and turning and stuff like that. It's a higher dimension of energy. Okay? And then you get to the other point, and without that higher dimension of energy, that's why I asked which state you think it is, if it's light or if it's the other way, because an Einstein-Rosen bridge isn't going to create light. It's going to create a massive amount of energy, though.
Well, check this. So with your Einstein-Rosen bridge, if you think about a spherical toroid, okay, your bridge is the in between the polarity, that goes from one point to another. The thing is that that's got a whole entire outside geometry. So you have one non-diffuse, concentrated, shorter point A to point B, which is just a beam, basically, indefinitely small. Okay, between point A and point B, high density, high concentration. But then you have this whole entire external thing that goes in a state of diffusion that's outside of it. And the reason that you're inside of the thing is what Nathan just said, which is your low resistance time dilation variance. So that's exactly what, when they show you the bullshit about like it's some kind of mat and it's checkerboards and bends, blah, blah, that's just like a way for dummies to fucking be like, oh, that's what gravity is or whatever. That's what, therefore time dilation, because time dilation, gravity, and space are all interconnected with one another intrinsically. Okay. The idea here is that it's permeative. So it's not really a flat grid. It's more of a three-dimensional grid, of diffuse gradient permeation. Based on resistance, which is directly correlated to the energy exchange, in which I keep on fucking vomiting out of my mouth as if it's like the greatest thing.
Flat grids are garbage. I don't know why they even thought of them or thought to say them. I wipe my ass with them. Those things are garbage. Stupidest thing you ever did.
Listen, you needed to tell somebody in 10th grade what gravity is. And I don't know how frequently you've dealt with like 10th graders.
You don't build a toilet bowl and tell them about gravity. You don't. You don't do it that way. Because then they'll start asking, well, where does the toilet bowl go? Where's the ball going? You keep showing it this thing going running around and it's going somewhere, right? And they go, oh, but you got to imagine this. No, your stupid ass showed it to me that way. Now just sit over there and defend it. Okay? You showed it wrong. It's not what you're doing. Okay? You're not creating that toilet bowl. It's stupid. When you want to match the experiment to what you're doing, you better get it accurately. Don't give me some cheap physics that shows it like a second grader. The second grader just tell you the same thing. That poo's got to go somewhere, pal. You know what I mean? It's the dumbest thing I've ever seen, and gravity doesn't work that way. No, hold on. You got to understand gravity does not work that way at all. It's a fundamental misunderstanding of how gravity even works. And then they keep pushing off as, oh, yeah, it's gravity. No, it's not. Dude, you're jerking your dick. It's not it at all.
I'm not defending them, but the fact is that the alternative to accurately describe it is generally incomprehensible to average IQ people, especially young adults. But it is, because at the same time, you have to be able to imagine something that doesn't exist in our physics. So I hate to tell you, I don't know what your dealings with people are, bro, but people imagining something outside of the here and now, beyond just a fucking desire dream is like sometimes impossible for a very large segment of the human population. And that's just simply the way. So if you try to explain to them that it's actually not like they show you, it's actually more like something displaced inside of a fish tank, except here's the thing, imagine the thing displaced in the fish tank, okay, also is fully permeated to a gradient degree with the substrate in which it's displacing. You know what I mean? They're like, what the fuck are you talking about, man? I'm in 10th grade. Or
I didn't make the rules in physics. I didn't write down this garbage in the first place, okay? That wasn't my fault. That's their fault. Okay?
I agree it's their fault, but when you're trying to teach something, it's like, you give them the bare minimum that they could generally absorb. And again, if you're dealing with 90 to 110 IQ people and they're also young and inexperienced, this is how you have to be able to give it to them in a digestible fashion. I don't disagree with how they give it. It's just simply not accurate.
No, because when you put things on a grid, okay, it means you have a piece of graph paper. You have no z dimension. They say, oh, no, we added the z, Did you use it? Let me ask you, did you use it? Because normally they don't. Their math is a equals b. Where was the c? Did you put the c in there? No. They didn't use it. They're just bullshit.
Hey, Johnny said something wonderful. He says, but in this, ground is needed. Yes. Material in a sea of energy is the ground state. That is your capacitance.
Dude, they don't even... yeah, dude, according to them, we're on Flintstones universe, and we all better get a little Flintstones car and start pedaling with our feet, because that's how we get around. And by the way, the rock in front of you is not really the rock in front of you. You know what I mean? And you can go around it because you're a millimeter thick and it's a millimeter thick, and you just move the paper. And that to them is how it works. And that's the dumbest thing I've ever heard in my life. They have no geometry in there whatsoever to convert some of this stuff. And the ones that do, you know what I mean? They don't quote them, they quote the idiots. That's why, when you see somebody's paper and all they're doing is flipping things around, no idea what they're doing. You can't just move things from one place to another. Dude, this thing is driving me nuts. Whatever that background crap is it's frustrating the living daylights out of me. Dude, when you start to see this thing in dimension, it makes it very easy. You see the rad, you see it built out. Dude, that's how it works. It's telling you, you're adding in the top and bottom states. You're adding in the vortexes, okay, is what you're doing. The anode cathode added in the vortexes. The rest builds out the exact same way it's supposed to build out in the solar system, okay, which means your entropy system is being taken out, and that you're putting it in with high voltage is what you're doing, okay? It's very simple, not hard. There's no toilet bowl in that, okay? There's none. The toilet bowl is upside down. No, the toilet bowl is upside down. Instead of going down the poo, it went back up, right? So it's adjusting the poo all the way around it, okay? This is why they say it's distortion, because their poo's coming out the wrong hole. They're shooting shit at each other.
There's toilet bowls. The thing is that the toilet bowls are coupled ass to ass, and when you're looking at it from one way, it's spinning all the same direction, but when you look at it from the other way, it's spinning all the same direction too, and it's inverted. And that's the entire point, because that's the middle matrix of the field coupling.
But that's Maxwell's demon. He's over there with his little lights. He's going, the shit comes this way. You know what I mean? Like he's boarding planes and stuff. He's like, this way. You know what I mean? And then they avoid each other. Dude, it's it's sad the way they look at it, dude. I'm sorry, you're never going to learn anything that way. You're going to be stumped in physics all your life. You'll never get out of it. Okay, Because there's people that swear to this day that's what it is, space-time. I don't know how many times people have regurgitated that garbage, okay? Space-time, space-time, space-time. Yeah, space and time are linked, but you don't have any idea how they are. You still think it's a toilet bowl, okay?
And just remember, there's no particles, just pulse and arc. There's no truth in stillness, only spark.
Oh, but a particle's everything in every size. It's just a round ball of energy.
Mm-hmm.
And why do you call them electrons? Why do you call them protons and neutrons? Why waste my time? You know what I mean? I could buy into the particle effect because it's just shrinking and growing. It's all about the pressure and the energy level inside of it. And that's it. Okay? You got me there. Other than that, dude, all the different names, just garbage.
All right. On that note, seeing as I just dropped the lyric from my song, anybody want to see the new music video to my old song?
There we go.
I don't know how many people caught it.
Joe is breaking the tension here.
Man.
Oh, Joe, you got it. Here we go.
Beyond this light are those who know and understand and love you. And they're willing to assist you in this process to experience more of this dimension. Ask for their guidance. Ask for their assistance. Be willing and open to receive.
I don't speak, I oscillate. Ride standing waves through the temple gate. Pitch my soul to the sacred hertz. Woke the void where the waveform hurts. Vortex breath through the spiral lung. Spun the word to the silence sung. I trace the echo in the mirrored dome. A fractal pulse from the ether's home. Resonance rights in a nodal cage. Modulated thought on a mythic stage. My mind's a tuning lattice strung. By sacred ratios unsung. I move through phase like gods through veils. My shadow drawn and intervenes. Trails the myth was masked. The truth is sway. A wave that bends what time can't weigh. Tune to the riff where matter's born. Dissonant monk in the world war torn. I bend the field with sacred spin where frequencies end and gods begin. I serve perturbations and thought forgot. Carve sigils and oppression, not no static law. Just flows to seed where vector paths and patterns meet. Torsion tongue with a semitic throat. Broadcast rise through a living mode. Map the choir in a spiral beam. While Plato's cave in a lucid dream. There's no particle, just pulse and dark. No truth and stillness, only spark. And I am that chaos align. The overtone of a hidden mind. I phase conjugate the sacred chant. Feed ghosts on martyrs to the vacant plan. Your physics stutter where I sang. Incoherent storms where empires hang.
Modulate flesh with an echo's kiss. Fracture the veil with the frequency hiss.
No God, just gradients in a wall. I built a throne in a wave-shaped dome. Tune to the riff where matter's born. Dissonant monk in a world war torn. I bend the field with sacred spin where frequencies end and gods begin.
Bringing in the shell of form, where sound becomes the unseen swarm.
And when the static world dissolves, I'll write the hum where truth evolves.
All right, that's that. Now it's gone live.
No, there you go. There you go. Okay, sorry about that, guys. I was trying to take care of some email stuff in the background while Joe song. Dude, that thing was awesome, by the way. You're you putting your face in there, man, and singing along and stuff like that. That was awesome.
Yeah, man. You know, it's a little hybrid thing, just like the music itself. You know, it's like I can't play all those instruments or do whatever, but I sure can. Play with the vocals. I sure can. Do the arrangement. I sure can take snippets of stuff and then generate stuff on top of it, and then bring it all together in a nice edit, so it's like the baby of my mind, in a very real fashion, but realized through the use of technology, which is really, really cool, and that's the unfortunate thing. And I hate to bring up AI again, but that is the unfortunate thing. There's some people, that use it as their in lieu of their brain, and then there's other people who realize that it's the paint, it's not the canvas, it's not the brush, and it's not the hand doing it, and it's certainly not the end product. It's just simply the paint, and if you're using artificial intelligence in that fashion to be creative, I think it's awesome because you're doing stuff that you probably wouldn't have been able to do otherwise.
Yeah.
But if you're using it in lieu of your common sense, your better judgment, or any applied thought process, well, then this is what's going to separate people in the future. Trust me. Trust me when I tell you, that will be the defining factor, is the people that use the tool versus the people who, get thought for. And that's it, man.
Yeah, for some people, AI is going to be therapy. They walk in, the AI is just a machine, and they go talk to it, and that's their therapy. For other people, it's going to be a resource. So, yeah, I get it.
That's it. My girlfriend wouldn't appreciate it if I went to her with every thought I had on, the physics and stuff, especially, if I went to her and I'm like, hey, let me talk to you about wave perturbation, or let me talk to you about, complex dynamic multi-field coupling, offset patterns, that occur, and where it runs into trouble and where it works, and therefore the geometric structures, that are in play both on both sides, but then combined to the two, it'd be and it's nothing against her or anybody. The fact is that that's just not a conversation you have with anybody.
My wife develops bladder issues as soon as I start talking about anything in physics. She's like, "Oh, I got to go to the bathroom." Yeah, I get it. You want me to go away? You know what I mean? That's exactly what happens. She does. Yeah, she's not into all that stuff.
I mean, listen, I'm going to give mine credit where credit's due. And it's actually a fault of mine, is that I get off of the show, man, or I'm done doing because I randomly work on this stuff throughout my week. I'll have a thought and I'll just start being on to myself, and she'll ask me about it, and I just kind of blow, I hate to say it and it's rude of me, I kind of blow it off. I'm like, oh, it was, the show was good. Well, what'd you talk about? I'm like, it's but that's on me. It really is, because you know what? Even if she's not interested, she still shows an interest. but like
Yeah.
it's just so much to have to be like, well, this is what we talked about, so let me start from the top on this. You have like 12 hours.
Yep. No, I get it.
Yeah. So
All right, Joe. It's been about 2 hours, Joe. I think we're gonna wrap it up here. Okay.
I think we're good, man. I think we are.
I just want to say this in closing, guys. With Tesla Tech, it's totally awesome. If you get a chance to go there, it's worth it. You watch the pay-per-view on it, it's totally worth it. If you have a chance to present at any time, go there. You know what I mean? Even if you don't get up on stage and you just show what you did over in the other room with all the inventions and stuff, it's completely worth it. You know what I mean? I saw some people over there, man, that just totally blew my mind. You know what I mean? And what they were doing and the stuff that was going on. So if you just want to enhance how you see things, or how things interact with each other, and people that are in agreement instead of everybody telling you no, it's a place to be. So I just with that, man, I want to say shout out to Vortex here, man, and I want to shout out to Darren right there, and Vortex again, man. Thank you guys very much for supporting me and the channel, man. I really do appreciate it. Right on, guys. I appreciate that.
Peace and love.
All right, guys. Have a great night.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.